Now next problem for pyramid. A hexagonal pyramid of 30 mm base edges and axis length 70 mm is lying on one of its base edge in the HP and parallel to VP. Draw its projection if the apex is in the VP and 55 mm above the HP. Now if you see the fifth problem we solved for pentagonal pyramid. Here in question the pyramid given is hexagonal. So we need to draw the base as hexagon. The similar problem we have solved for pentagonal pyramid. If you see the fifth problem, there also that apex is given by some distance above the HP. So now we'll see how to solve it for hexagonal pyramid. Since the base edge is lying in the HP, so first assumption is the entire base is lying on the HP with one of the base edge perpendicular to XY line and on the right hand side. But since it is a hexagon, we'll get two edges parallel to each other which will be perpendicular to XY, and one will be on the right and one will be on the left. And so we will start with the top view, as the hexagon will be seen as a true shape, that is the base in first stage in top view, because the entire base we are assuming that lying on the HP first. Now be careful, we are solving for hexagonal pyramid. Previous all six problems for pyramid were based on pentagon. Now again it is a three-stage problem. So first, hexagonal pyramid, we can use circle method for drawing hexagonal base below XY line. So for that I'll take 30 mm radius and draw the circle. This circle should be light because we want hexagon, not the circle. Now, as I discussed earlier, for getting two edges vertical in the hexagon, I should take help of vertical diameter to mark the arcs and not the horizontal diameter. So here I will draw the vertical diameter first, which will be perpendicular to XY line. Okay. So with this vertical diameter, we'll take the same distance in compass, and both the ends of that vertical diameter will mark two arcs to get the divisions for drawing the hexagon. Similarly for from the other end. So obviously after completing the hexagon, we'll get two edges perpendicular to XY, and one which will be on the right hand side and one will be on the left hand side. So for hexagon there are two possibilities, with two edges perpendicular and with two edges parallel to XY. For making parallel lines, we have to take the help of horizontal diameter and not the vertical diameter. So here one of the base edge is in the HP. So we should draw the one base edge perpendicular XY and on the right hand side. So this completes the base. Again, there is no need to mark the center of the base using the method as that of pentagon, because it is already giving me the center of the circle as the center of base. Now we'll start numbering again. 1, 2, 3, 4, 5, 6. You can start numbering from anywhere. No such rules for numbering. Then this will be OO. Apex and center of base will coincide. Now I should mark the slant edges also. Means joining the apex with each corner. So O5, then O2. We need to simply join the opposite corners for this hexagon to get the slant edges. Now in second, we'll complete the front view. For that we need to first produce the axis up to length of 70 mm. That is the height in front view. So we need to just produce this vertical diameter to height of 70 mm. and here we will see whether to draw it long dash, short dash, or a dark line. And along with these two corners, we need to project remaining corners up to xy line only. So 3 and 4 up to xy, and then 1 and 6 again up to xy. I will give the corresponding notations 3 dash, 4 dash, then here it will be 2 dash, 5 dash, then 1 dash, 6 dash. We have marked 70 mm length up to here, so we'll join the slant edges in front view. Then base is dark. Now slant edges from 2 and 5 will coincide with the axis, and from the slant edge from point 2 will be visible. So we'll give the preference to that visible slant edge, so it will be dark. So here no need to show long dash, short dash for axis, but we can show the notations O dash and O dash here. Okay. Now in second stage, we need condition with the HP, which is given the apex is in the VP and 55 mm above the HP. So condition given with respect to VP will be used in third stage while redrawing the top view from second stage. But here we will use only this condition, that apex is 55 mm above the HP, but while doing this we should keep the base edge still in the HP. For here the reference base edge kept in HP is 3 dash, 4 dash. So I'll first fix the point 3 dash, 4 dash here for second stage, and then we'll mark height of 55 mm and we'll draw a parallel line to XY on which we are going to get the apex. This we have already done in fifth problem for pentagonal pyramid. There the distance was 40 mm above the HP. Here it is 55 mm. So we are just first marking the locus at 55 mm. Then apex is, initially the apex was at height of 70 mm. So in second stage we need to tilt this pyramid in such a way that apex come at the height of 55 mm. So I'll take this distance 3 dash, 4 dash up to O dash. Since the position of 3 dash, 4 dash is fixed because that edge need to be in HP, so we'll mark this distance to get O dash above the HP at a distance 55 mm. So this will give me O dash. Now I can complete this triangle getting 1 dash, 6 dash. Then again with respect to O dash, I need to take distance for 1 dash, 6 dash. Okay, now we'll complete that triangle and we'll mark the same visibility again. Again we need to mark this point in between, which is 2 dash, 5 dash, O dash. That is again a dark line. So 2 dash, 5 dash, O dash, and this is 1 dash, 6 dash. Now we'll complete the corresponding top view by projecting vertically and horizontally all the corners. Then we'll mark the visibility also. Then last is apex. Similarly, from top view, you need to project horizontally. Again, now the projector from 1 and 4 and 6 will coincide. Some error is there, but still they will coincide. Then 1 and 3 again will coincide, and then at the end 2. Okay. Now we'll locate the points 1 dash and 6 dash. So 6 will be here, 1 will be here, and 2 and 5, 2 will be here, 5, then 3 and 4, 3 and 4, then center of the base. For center of the base, we need to project from the center of the circle, which is the center of the base for hexagon. So I'll get O here. Again, this will be the apex. So now for visibility, we'll see the observer position. For the observer from this direction, the base is not visible to him. So all the base edges, excluding the edges lying on the boundary, will be dotted. So first we'll mark the boundary. So 5 to 6 is on the boundary. Now we'll get the apparent hexagon here, not the true hexagon. 1 to 2. Then 4 to 5 is again on the boundary, one of the slant edge. Then similarly 4 to 2 will be on the boundary. Okay. Now 3 dash 4 dash, both the corners are away from the observer. So all the 3 edges starting from each point 3 and 4 should be initially marked dotted, and if any one of the edges lying on the boundary, then it should be made dark. But here if I draw the 3 edges passing through 4, there will be one base edge O4 that should be dotted, but since it is not lying on the boundary, it will be kept as dotted only. Then O24, one of the slant edge, again dotted, not lying on the boundary. Then 3 to 4, one of the base edge, again dotted, not lying on the boundary. 2 to 3, because 3 and 4 are the farthest points from the observer, so all the edges starting from 3 and 4 will be marked dotted and will be kept as dotted only if they are not lying on the boundary. That is one of the important rule of visibility. Okay. Now we should mark 6 base edges and 6 slant edges. So out of 6 slant edges, we have marked 1, 2, 3 and 4. So remaining are O21 and O26. Since O1 and O6 are nearest to the observer, so they will be dark lines. O21 is a dark line. Again, O26 is a dark line. Okay. Now this completes the second stage. But in third stage, we want condition with the VP. What is given for VP is the base edge which is in the HP is parallel to VP. So base edge which we considered, which is 3, 4. So we want to make it parallel to VP. So that's why we need to make it parallel to XY line. So this will be tilted 90 degree. But now, depending on the position of the apex, we need to decide how should I tilt, clockwise or anti-clockwise. That means for the apex, what is given, apex is in the VP. Means after tilting, this O should be in the VP. That means this O should touch the XY line. So I need to tilt this entire top view in anti-clockwise direction by 90 degrees such that O will lie on the XY, and at the same time this edge of the base which was initially kept in the HP, which is 3, 4, will become parallel to XY. Okay, so we need to tilt this 90 degree clockwise, anti-clockwise. So for that we will start with again rectangle method. So we need to mark this rectangle first, and obviously if I want to make this edge as parallel, then this edge of the boundary of the rectangle will be also parallel, and also this edge. Now since we want O on the XY line, so we will draw this boundary on the XY line. So I'll take this much distance. I'll fix any point on the XY line first. Now I'll take this boundary of the rectangle on the XY line, because we want O to lie on XY line only, because apex we want on the HP. Okay. Now with this we will complete the remaining rectangle, means this edge and this edge. So first we need to draw a perpendicular. So for that we can directly use set square also. We need to measure that 90 degree angle. Now on this we will mark this length of the rectangle, which will be same as this length. So we are going to mark these two lengths. We will complete the rectangle. So now, after drawing the rectangle in which this entire top view is included, we can mark the remaining points. So for that, first I need to locate the center of this rectangle to mark O. So first I'll take this distance or this distance for marking the position of O. So O will be here, and on the same line we'll get the center of the base. So we will draw a parallel line from that arc. Okay. Now next step is mark the remaining points. Now this edge is coinciding with XY, so I'll mark remaining points with respect to these points. Or we can start from here and we'll take the distance from this corner. So to mark 5, I'll take reference of this corner, but it will be tilted like this. So this corner will go to this position, and this it will be tilted like this. So this will come here and this will come here. So we'll mark the points accordingly. So for 5 and 2, we'll keep the same distance, and that need to be marked from these corners, because after tilting 90 degrees clockwise, this horizontal distances will become vertical distances. So here the 2 will come here and 5 will be here. Then with the same corners we can mark 1 and 6. So 6 and then 1 will be at the same distance due to symmetry. So we will take that distance for marking 1 and 6. So obviously point nearer to 2 is 1, we'll get here, and then 6. So this is 0.6 and this is 1. Then to mark 4 and 3, we can first draw we can first mark this O on the same line, because this is the apex. On the same line we are getting center of the base, which is O here. Then for drawing 3 and 4, we'll take this parallel distance from the boundary of the rectangle. Okay, and we will draw a parallel line at that arc. And again we can cut the equal distances on both the sides from the center line to get 3 and 4. Obviously they are lying on the same line from 1 and 6. So instead of doing that, we can just draw lines passing through 6 and 1, and where that cut initially marked parallel line will give me corresponding points. Okay, so here I am getting 4 and here it will be 3. Now we have marked all the points, so we can just join with the same visibility. So first marking the boundary arc. Then slant edges, and 4 and 3, everything is dotted from 4 and 3. We will keep the same visibility for 4 and 3. All lines passing through 4 and 3 are dotted. Then 1 and 6, the slant edges are dark. in this stage we have satisfied two conditions. First is making the base edge parallel to VP, which is 3 4, and then keeping the apex in the VP. Okay, so now we'll complete the final view. By just projecting all points, corners in the front view. So 4 and 6 I'll get one projector, then OO again one projector, then 3 1 again one projector, and last for 2 I'm getting my projector. Okay, and similarly from front view we'll project horizontally, then 1 dash 6 dash, then 4 dash. Okay, now we'll mark each point. So sorry, we forgot to project from 5. Okay, so for first marking 5 it will be here 5 dash, then 4 and 6. So 4 is on the xy, 4 dash, then 6 here 6 dash, then 1 and O and O. Center of the base will be here O, and apex will be here O dash. Then 1 and 3 will be on the xy 3 dash, and 1 will be along line from 6, so 1 dash, and then finally 2 dash will be here along the same line from 5. Now we'll see how to mark the visibility. For that we'll first decide the observer position, and now for the observer, still the apex is in the VP, it is the farthest point for the observer. So initially all the points passing through the apex are marked dotted except for those lying on the boundary, the edges starting from O dash. Now this is the apex and this is the center of the base. So initially all the lines passing through apex, so I'll get 6 slant edges from apex. So out of that, O dash 6 dash is on the boundary. O dash 5 dash is not on the boundary because it is lying inside O dash 6 dash. Similarly, O dash 2 dash is lying on, O dash 1 dash is lying on the boundary. Again, O dash 2 dash is not on the boundary because it is inside, and all the remaining edges are also inside. So first we are making it dark, the boundary lines. Then again for base, O dash 5 dash, 4 dash 5 dash boundary, 3 dash 4 dash again a boundary, 2 dash 3 dash again a boundary. Okay, then 5 dash 6 dash again a boundary, and 2 dash 1 dash again a boundary. Okay, so now we are left with 1 dash 6 dash, one of the base edges, but since it is nearer to the observer, so it is visible. So remaining one base edge 1 dash 6 dash is also dark. So entire base is visible to the observer. Okay, now we'll think about the slant edges. So as I discussed initially, O is the farthest point, so all the lines starting from O dash apex are dotted. So out of that we have marked two edges dotted, O dash 6 dash and O dash 1 dash. So remaining, which are O dash 4 dash, O dash 3 dash, are dotted because 3 dash 4 dash is also away from the observer. Similarly, O dash 5 dash and O dash 2 dash are also not lying on the boundary, and they are starting from the farthest corner, farthest point apex, so they will be dotted. Okay. one more thing, one more rule of visibility: no two dark lines will cross each other. So if you are confused between these dotted lines, whether they should be dotted or dark, then remember that 1 dash 6 dash we already marked dark, so no other dark line should cross it. So obviously these remaining lines should be dotted. So that is one more rule of visibility: no two dotted or dark line should cross each other. So this completes the solution for this particular problem. But in addition to this, we will mark the dimensions. Base edge of the hexagon is 30 mm. Then axis height is 70 mm. Then this distance in second stage, that is apex at a distance of 55 mm. So we'll show that here. And then in third stage, this is parallel, so no need to show the angle. That base is parallel to VP and apex is in the VP. So this is the final stage. Just check once again whether we have forgotten any lines or edges. No, 6 slant edges, 6 edges of the base. So this completes the solution for this particular problem.